When humans first managed to harness heavier-than-air flight, they did so by using piston engines and propellers. Several decades later, a more efficient means of propulsion was developed. It could make planes travel faster and higher, and would use less fuel over longer distances. In addition to transforming civilian and military aviation, new modes of it still have the potential to revolutionize the world once again. Learn more about jet propulsion, how it works, and how it was developed on this episode of Everything Everywhere Daily. This episode is sponsored by Heaven Hill Bottled and Bond Bourbon. I recently had the chance to try Heaven Hill Bottled and Bond, and I can attest to its exceptional aromas with hints of caramel and vanilla intertwining with its oakiness, which provide a well-rounded flavor profile. Taking a sip is akin to experiencing a piece of bourbon history firsthand. Heaven Hill Distillery may be America's most quintessential bourbon distillery. Established in 1935 after the end of Prohibition, the distillery was established by the Shapiro family and has remained a family-owned distillery to this day. In 1897, Congress passed the Bottled in Bond Act, which set forth strict rules for any bourbon labeled Bottled in Bond. Heaven Hill Bottled in Bond Bourbon goes beyond the stringent requirements of the law by aging its bourbon for 7 years, not 4. The end result is a gold medal-winning bourbon that truly stands out. Available nationally, look for a bottle at your local store. Heaven Hill Bottled in Bond. Heaven Hill reminds you, think wisely, drink wisely. This episode is sponsored by ButcherBox. You've probably heard the old adage that you are what you eat. Nowhere is this more true than with the meats and seafood you consume. That's why ButcherBox sources only the highest quality meats and seafood. All of their beef is grass-fed and grass-finished. All of their chicken is pasture-raised, and all of their seafood is wild-caught. And they do this by finding only the best producers who can meet their high-quality standards. Make a commitment to eat better this year with the best meat and seafood on the planet delivered directly to your door. ButcherBox is offering my listeners their choice of a weeknight meal essential: 3 pounds of chicken thighs, 2 pounds of ground beef, or 1 pound of premium steak tips, for free in every order for a whole year. Plus, you get $20 off your first order. Sign up today at butcherbox.com/daily and use code DAILY to choose your free offer and get $20 off. Most of you would probably recognize a jet engine if you saw one on an airplane. However, most people probably couldn't really explain how a jet engine actually works. A propeller is somewhat more intuitive in how it works, but a jet is a bit more tricky because much of it is encased and you can't see what's happening. So, let's start with the basics. What is a jet, and jet propulsion in the most generic sense of the word? The dictionary definition of a jet is, quote, a high-velocity fluid stream forced under pressure out of a small diameter opening or nozzle. The fluids usually used in jets would be air or water. Jet propulsion, therefore, is the propulsion of an object in one direction, produced by ejecting a jet of fluid in the opposite direction. Jet propulsion is nothing more than an application of Newton's third law of motion, which states that for every action, there is an equal and opposite reaction. You throw something out backwards at a high velocity to make something go forward. This might sound familiar. If you remember a previous episode, rockets use the exact same principle. They create a superheated gas that is expelled out of the nozzle to produce thrust. So, are jets the same as rockets? Well, no, but they are much more similar than most people realize. Both are considered to be what's called reaction engines. Both rockets and jets oxidize a propellant with the resulting gas from the combustion providing the thrust. The difference is that rockets carry the oxidizing agent with them, usually in the form of liquid oxygen. A jet, on the other hand, gets its oxygen from the atmosphere. A rocket can operate in the vacuum of space, whereas a jet can only operate in the atmosphere. So, what exactly is happening inside of a jet engine? Most jet engines you've probably seen on commercial aircraft are cylindrical, but they actually don't have to be. All that is required is that there is an opening for air intake to enter and an exit for exhaust to leave. In most jet engines, air will be brought into the engine via a fan. The fan allows for air to enter the jet when it's traveling at lower speeds. Once air enters the air intake, it is then compressed in stages, sometimes by other fans called rotors and sometimes by stationary blades called stators. Once the air is compressed, it's mixed with fuel and it's ignited. The product of the combustion is a hot gas that dramatically expands in volume. With the air entering in one direction, the easiest path out is in the other direction, which ends up providing the thrust. There are roughly two types of jets that are used in aviation today, although there are more, which I'll get to in a bit. The two are turbojets and turbofans. A turbojet is basically what I just described. All of the incoming air goes through the combustion chamber. At lower speeds, it's less efficient and it's much louder. A turbofan is where only part of the air is compressed and enters the combustion chamber. The exhaust from the combustion chamber is used to turn the fan that's in the air intake section. The rest of the air goes around the combustion chamber and provides thrust just like a propeller does on an airplane. Turbofan engines tend to be more fuel efficient and quieter. Most of the jets you see on commercial aircraft today are turbofan engines. You may have heard of an engine called a turboprop. These are not jet engines. They are propeller engines where the exhaust from the engine that drives the propeller is expelled to provide a bit more thrust and more efficiency. The exhaust is not the primary source of thrust, but it does help a little bit. So why are jets better than propellers for powering an aircraft? Propellers have some very hard limits. For starters, it is extremely difficult for a propeller-driven aircraft to achieve very high speeds. The fastest speed ever recorded for a propeller-driven aircraft is only Mach 0.82, or 82% the speed of sound. The reason why propeller-driven aircraft are limited has to do with the tips of the propellers. Because a propeller moves in a circle, the tip of the propeller is moving much faster than the rest of the propeller because it has to travel a longer distance around the circle. The tips of the propeller will break the speed of sound first, causing a great deal of turbulence, which ends up slowing the airplane. The other problem has to do with altitude. The higher the altitude, the thinner the air, and the less efficiently propellers work. However, propellers work very well at lower speeds and can take off from shorter runways. I remember once being picked up in northern Manitoba by a bush plane called a Beaver. The plane landed on a short stretch of sand, and we literally had to dig the plane out of the sand when it got stuck like it was a car stuck in a snowbank. But it managed to take off on the very short stretch of sand that it landed on. So a jet engine allows planes to fly higher and faster with greater fuel efficiency. So how did jet engines develop? Jets, again using the generally defined high-velocity fluid stream under pressure, can be found in nature. Certain species of cephalopods will squirt water out of a jet to flee from predators. If you remember back to my episode on the steam engine, the very first thing that could be called a steam device was created by Hero of Alexandria in the 1st century. He heated a sphere filled with water, and when it was heated, jets of steam came out of 2 exhaust valves. It's not usually considered a jet, but it was a jet of steam, even though it had no practical application. The origins of what we would recognize as a jet engine began with the development of the gas turbine engine. A gas turbine is a continuous flow engine that turns a turbine as opposed to a piston-driven engine. The idea for the gas turbine engine was first developed by English inventor John Barber in 1791. In 1921, a French agricultural engineer named Maxime Guillaume first suggested using a gas turbine in an aircraft. Unfortunately, given the state of technology at that time, his idea wasn't practical. However, by the 1930s, aviation engineers in both the UK and Germany began working on jet engines. In Germany, Hans von Ohain led the German effort to create a working jet aircraft, and in England, Frank Whittle was doing the same thing independently. Both men are credited as the co-inventors of the jet engine. Whittle created his first working prototype in 1937, as did Ohain, who built his engine, the Heinkel HES-1, that same year. Whittle lacked funding and government support, so it was Ohain who wound up creating the first jet aircraft. The Heinkel HE-178 flew for the first time on August 27, 1939, just 4 days before the start of the Second World War. Whittle's engine eventually led to the flight of the Gloucester E.2839 on May 15, 1941, Britain's first jet aircraft. The war accelerated the development of jet engines and jet aircraft. Jet-powered aircraft had a significant advantage over propeller aircraft in terms of speed and maneuverability. However, they ended up seeing very limited action in the war. The German Messerschmitt Me-262 flew in 1942, and the British Gloucester Meteor flew in 1943. Both aircraft saw limited action because they weren't able to be mass-produced in time by the end of the war. However, after the war, almost all aviation engineering efforts went heavily into developing jet aircraft. While the initial push was for military aircraft, civilian jet aircraft was close behind. The de Havilland Comet, introduced in 1952, was the world's first commercial jet airliner. The Comet had serious problems that were unrelated to its jet engines. Within its first year of service, 3 Comets were involved in deadly accidents, 2 of which occurred in mid-air. The problem was with the metal in the airframe. It wasn't until 1958, when Pan Am introduced flights on the Boeing 707, that the jet age truly began in commercial air travel. The 707's inaugural route was between New York and Paris, offering the fastest way to cross the Atlantic. Jet aircraft proved to be so popular that by 1959, for the first time in history, more passengers crossed the Atlantic by air than by sea. Jet engines, in particular the adoption of turbofan engines, allowed for larger aircraft that could fly higher and further, most notably the Boeing 747, on which I've done a previous episode. These aircraft allow people to travel internationally quickly and created a group of wealthy people who became known as the jet set. Jet aircraft were so popular that the New York City American Football League team, the Titans, actually changed their name to the Jets in 1963. Jet engines became dominant in commercial and military aviation by the 1960s, but there was still a role for propeller-driven aircraft, as propeller engines are cheaper to produce and are more efficient at lower speeds and shorter distances. Jet engines have seen constant incremental improvements in efficiency and power over the last 60 years. However, there is still more innovation on the horizon using jet engines in aircraft. One of the biggest desires in aviation right now is to see a return of supersonic commercial air travel. The only supersonic commercial aircraft was the Concorde, and the Concorde used turbojet engines rather than turbofan engines because of the high speeds it flew at. If aircraft are going to fly faster in the future, they're going to need advanced engines, and one of the proposed engine designs is called a ramjet. The principle behind a ramjet is exactly the same as a turbojet. The only difference is that a ramjet doesn't have any moving parts. A ramjet relies on the speed of the aircraft to bring air into the combustion chamber and uses the speed of air and the geometry of the engine to compress the air. Computer modeling shows that ramjets would work most efficiently around Mach 3. However, if you want to go even faster, there's a version of a ramjet known as a scramjet. A scramjet is designed for combustion at hypersonic speeds. NASA has been working on scramjet technology, and in 2004 they flew the X-43A, which managed to reach speeds of Mach 9.6. There's still a lot of work to be done on jet aircraft that fly at hypersonic speeds. One of the biggest problems is that the engines that work well at high speeds don't work very well at low speeds, and aircraft have to start from nothing. I should also note that jet propulsion isn't limited to just aircraft. Watercraft can be powered by water jets as well. The method of creating the water jet is very different than how an aircraft jet engine works, but the physics of propulsion are pretty much the same. A watercraft, like a jet ski, simply uses a water pump at high speeds to create a jet of water to provide thrust. Pump jet engines tend to be safer, as there's no exposed propeller. They can operate in shallower water and have higher power densities and are also more maneuverable. I'll close by making one observation. Most people, even if they have flown in a jet aircraft, really don't viscerally understand the raw power of jet engines. In the cabin of a plane, you're safely away from the engines. However, there is one place I know of where you can experience the power of large jet engines. On the island of St. Thomas in the Caribbean, at the end of the airport runway, is a beach. When large jumbo jets are ready for takeoff, they sit at the end of the runway and rev up their jet engines, blowing the exhaust right into the beach and everyone on it. I was there for several jet takeoffs, and the air coming out of the jet engines was so powerful that it would knock most people off their feet. Jet propulsion has been one of the biggest innovations in aviation in the second half of the 20th century. They've allowed aircraft to fly faster, longer, and higher. Despite having been introduced over 80 years ago, all of us are still living in the jet age. The executive producer of Everything Everywhere Daily is Charles Daniel. The associate producers are Benji Long and Cameron Kieffer. I want to give a big shout out to everyone who supports the show over on Patreon, including the show's producers. Your support helps me put out a show every single day. And also, Patreon is currently the only place where Everything Everywhere Daily merchandise is available to the top tier of supporters. If you'd like to talk to other listeners of the show and members of the Completionist Club, you can join the Everything Everywhere Daily Facebook group or Discord server. Links to everything are in the show notes.